Give me just a second. All right. I need to use my other laptop now. Test and prod, baby. Let's go. One more second.
Cool. Looks like it's working now. Okay. Thanks. Okay, so I can start now.
Yes.
Cool. So, yeah, thanks everyone for waiting. Start now.
Yes.
Are we ready now? So,
Ahmed,
yeah, thanks everyone for waiting. Start now.
Ahmed,
can you hear me twice? I don't know where. Can you hear me twice? I don't know where.
Ahmed, make sure you're unmuted on Restream and muted on Discord.
Yes, I'm unmuted on Restream, I'm muted on Discord, but I can hear my voice. I don't know. Ah, it's here. I have to...
I just moved you guys to the audience. There's no need for you guys to be like on the speaker role. They can see you guys here, so you don't need to hear yourselves twice. So you're good to go.
Okay.
No need for you guys to be like on the speaker role. They can see you guys here, so you don't need to still hear me, right? Hear yourself twice, so you're good to go. Okay. Just mute yourself. Like you see, like the headphones at the bottom. You can still hear me, right? Hear yourself twice, so you're good to go. Okay. Just mute yourself. Like you see, like the
Wait, I'm hearing everything twice.
Okay, you can still hear me, right? Hear yourself twice, so you're good to go. Okay. Just mute yourself. Like you see, like the
Wait, I'm hearing everything twice.
You need to mute the tab. Mute the tab.
Okay, just mute yourself. Like you see, like
Wait, I'm hearing everything twice.
You need to mute the tab. Mute the tab. You need to mute the tab. Mute the tab. You need to mute the tab. Mute the tab.
Okay, so we found the culprit. It's actually you, Raza. I think you have something like a stream open or something. But it was your audio that was getting returned. So Ahmed, try it now. Say something.
Can you hear me now?
Yes, I can hear you.
Okay. Yeah. Thanks everyone for for waiting. Yeah. So we're good to go now?
Yeah. Go ahead.
So
Raza, try saying something yourself as well, so we can test that as well. Go ahead.
Just to be safe, I'm gonna stay on mute.
Okay.
We can hear you, yeah. Okay, so yeah, finally, let's get started. Yeah, we're going to start by cloning this repo. You can follow it yourself with me, or you can just chill and watch me code and ask questions and then try it on your time, because this is going to be on YouTube, I think, right? So yeah, what you need to get started is only a MetaMask wallet and with Sepolia ETH. This is on Scroll Sepolia. Oh, by the way, Juan, I'm going to later need to just close my MetaMask and reopen it, because I want to. I don't want to show my private key. So yeah, but that will be later on the live stream. But yeah, that's the only thing that you need. You need Sepolia ETH and your MetaMask installed. You can also do this on any other EVM chain as long as it supports all the precompiles. So yeah, in terms of TK EVM, you can only do this on Scroll, but on the other EVM, optimistic rollup, or Ethereum layer 1, you can do this too. So Goerli and Sepolia included. So the first thing that we're going to need is we're going to be using Noir to generate the circuits. If you're not familiar with circuits, here you can. I have already installed, but you can just use this or these commands to install exactly the version 19.4 and of Nargo. Oh, actually, I don't have it, so I'm going to install it. So you can use this to install this specific version. And yeah, so here is on Linux and on Mac. And Nargo is going to be on charge of doing these constraints and generating the proofs. And if you're not familiar with circuit, generating a proof is how you can make stuff private. You can think about sending a private input to a smart contract, which at the beginning for me it sounded like crazy. Like, how can you send a private input to a smart contract? And that's possible because everything is encrypted on the proof, on the generated proof. And yeah, this is what Nargo is going to do for us, and we're going to see more about it in a minute. So as you can see now I have Nargo 19.4 installed, and I'm going ahead and run the first part, which is the first part, which is generating a Solidity file. Oh, I think I need some extra libraries. Another thing that I have to. Oh no, but it was generated fine. So, so here is the circuit. If you're familiar with Rust, as you can see, Noir looks a little bit like Rust, but here the idea is a bit different than programming, but still very similar. You can use ifs, you can use conditions, you can use loops, you can call functions. Here, as you can see, I'm using a library, but the different thing with Noir is that we are, instead of like executing functions and changing the state, what we're doing is we are asserting that some information is valid. So we're verifying stuff here. So it's a little bit of a different mindset. But yeah, it's not, as you can see, it's not much code here, but you can do a lot of stuff. And what we're doing is that we are passing 4 parameters, actually only 2. This is our public key, basically your address. This is this address. This is your public key. This is like what identifies you on the blockchain. And we are just passing it in a different format. This public key X and Y is just like a different way of representing your public address, but it's basically the same. And the second parameter is a signature. So we are not going to execute directly stuff in the blockchain because you will lose your anonymity. We're going to talk more about that later. But instead of executing a smart contract, we're going to sign a message just like this. So we're passing that signature as parameter that we're going to grab from the front end. And the last parameter is a hash message. So we are going to first hash a message and then sign the message, and then we're going to create a proof from that. So and what we're going to prove is that the signature is actually valid, and that way we are going to anonymize or hide all these 3 parameters, and only this last parameter is going to be public. And as you can see, Noir has this pub parameter, pub like reserved word that will just make only this parameter private, because everything is this is going to be public because everything else by default is going to be private. So yeah, maybe at this point, if you're not familiar with Noir, you may have some questions, but maybe when we try it, you will get a feeling of it. The cool thing about this, when we run this command, this codegen verifier, the cool thing is that it generated this. As you can see, we're familiar with this. This is Solidity, and there is a lot of crazy stuff in there that we don't need to understand. It was automatically generated, but the important part is that it has a verify function that where you can pass a proof and some public inputs, and yeah, it's going to verify if this proof is correct. So you can use this and add logic on your other smart contracts. So you can use all your Solidity knowledge and combine it with this, and you will be able to just create new cool privacy enabled smart contracts. So I'm going to go ahead and I'm going to go ahead and just launch this smart contract on Scroll. This, let's see which version is it using. Okay, so we can use whatever. I'm going to compile it. Oh, you have to enable some optimization because otherwise it won't work. So you enable the optimizations, and then you launch on, this is Scroll testnet, and you launch the Ultra Verifier. It's called Ultra Verifier because it's using UltraPlonk. And the cool thing about UltraPlonk is it has new cryptographic cool stuff that enables ECDSA verification, which basically means that enables this like signature, like this good user experience that you just MetaMask pop-ups and you sign, and then you will be able to verify it from a smart contract. So yeah, that's the cool thing about UltraPlonk, and that's why we're using the Ultra Verifier, which I always find funny. All these Plonk names. Like I don't know if maybe you have heard about TurboPlonk, UltraPlonk, and now you have Nova and Supernova. Yeah, I think it's just that's very silly and fun names. Okay, so we are going to go through 4 steps. One is the circuit, which is already done, and then the next step is going to be the smart contract, which we're going to launch now. So this is a smart contract that it doesn't have like many weird stuff, but it does have this a little bit weird EIP 712 thing that you can bypass this, but this will give users like a very good experience. So MetaMask will pop up and will give you a lot of information about what you're doing exactly, because maybe you have interacted with protocols that ask you to sign a message, but the message is just like some random hash that we don't understand. It's not readable for the user. But with DCIP, it will be MetaMask will pop up and will show exactly, will explain you exactly what you're doing. You know what you're signing, so it's more secure. But you need to do this a little bit weird thing on the smart contract. But it's not too hard to understand. But I'm going to explain it once we try the demo. What I want you to see at this point is just look at this. This is like your normal Solidity logic that you're maybe used to. So we're going to have titles and text, because as you remember, this is a message board, so you can send a message, and each message has a title and a text. And then we can, when you send, like, you can ignore for now the proof and the public inputs, but the thing is that we're going to send a title and the text, and it's going to be stored in the contract, like in the state. But on top of that, it's going to be verified. So it's going to be verified that the message was properly signed, was properly, it's that everything is correct. And by doing this verification, we will also verifying private inputs with the circuit, which is this is the cool stuff. And also there is some other, like, just very yeah, just some extra functions that I have to add. But yeah, you don't have to worry about it. I think that the names are very self-explanatory. Converting a new into string, converting an address to a string. But yeah, this is you don't need to this is like just like some extra work that you have to do, but the important part is on the smart contract. Also, if you find better ways of doing it, I did this, like I didn't like optimize it. I just grabbed some very old code from Stack Overflow in some parts. So I think here there should be a lot of optimizations or more, I don't know, elegant or easy ways of doing this. But yeah, so far it's working. I'm very happy for this because I think this is the first EIP 712 example available with CK. So yeah, I want to keep this polished. And yeah, so if you want to, yeah, so don't think that this code is super polished and audited, anything like that. So yeah, also yeah, so pull requests super welcome, especially on this part. So yeah, I'm going to launch this verifier, and as you can see, the comment verifier contract that holds the solidity logic what we used to, it needs a parameter in the constructor, and the parameter is the verifier. The verifier because we're going to use the verifier function that we already deployed, this one. So we are going to pass the verifier contract to this other one, and we're going to launch it. And by the way, usually in any CKDSL, we're using Noir now, but just keep in mind that all the other DSLs usually work like this. And yeah, it's very similar. You have a smart contract verifier that you deploy, and then you reference that smart contract from another smart contract where is your actual logic. And yeah, this is exactly what we're doing here. So Socrates, Halo 2, there's Circom, yeah, all there's the command names obviously are different, and the API may be different, but it's the same idea. Okay, so next we are going to so step 1 was generating the solidity verifier. Step 2, deploy this verifier smart contract. We just deployed it. Now step 3 is going to launch a relayer, and in order to do that, we're going to fill some environment variables, as you may be familiar with. So let's start by the relayer. So in the relayer, we're just going to copy the example, this one, and we're going to submit an RPC URL. So if you're deploying this in other chain other than Scroll, you just need to change this. The comment verifier address, it's this one that we just deployed. The second one, the one with the solidity logic. And then the relayer address, you can pick whatever. You need an EOA wallet, an end user account wallet. So you can pick whatever, or maybe I can pick this one. You can pick whatever you want. And at the end of the day, someone needs to pay for the gas. And the transaction is going to be signed, but it's not going to be, but someone needs to relay it. So it's going to be this address. He's going to pay for the fees. There's also like a huge topic about relayers, because you need to incentivize and the relayers, and also keep the system in a way like in a so everyone can send transactions, and they can't be it doesn't have to be like permission. You need a permissionless system that everyone is able to send transactions, and the relayers are incentivized. You can look, for example, at what CowSwap is doing. Is a DEX, but it's using relayers. They don't use CK, but they use a relayer system, and they incentivize you need to ways to incentivize the relayers. We're not doing this in this part. We're just going to have like a very small relayer and using Ether.js that's just going to pass any transactions. And by the way, I'm very happy with this relayer because this is using the latest version, the layer Ether.js version, which is very new. Doesn't have a lot of documentation, but yeah, this code is working. It just relayers transaction in a very like naive way. But just keep in mind that you need to think about if you're looking into building your own CK dApp, you need to think about ways of subsidizing the relayer. So also we're also going to need to pass the private key. So I'm just going to stop streaming and just hope that I'm able to stream back again when I go back. So just give me a second. Right now I'm just copying my private key from MetaMask. Just give me a second. Also, if you have any questions or any comments, you can share them. So let me see if I can put my screen back again. Oh, we need someone to put it back in. Nice, thank you, Raza. So yeah, I just put my private key in there and I close the file. So the relayer should be good to go. So we're going to run these commands. So we are going to go to the relayer directory. Also, I'm going to use Node version 20 just in case. Yeah. Oops. Oh, I think I need to maybe I missed Express. Okay, there you go. Yeah, I need to add this to the package, JSON package file. Okay, so now the relayer is just listening to the port 8080, just waiting for transactions to be relayed, and we're going to leave this relayer here in this terminal tab. I'm going to open a new tab, go back to the previous directory. Also, I'm going to be using Node version 20. And we're going to go to the last part finally, which is the web app. And on the web app, we also need to set up an environment file, but this one it can be public, so no issues there. We just need to pass the comment verifier address. Remember that the comment verifier is the one with the solidity logic, this one. And yeah, that's going to be it. We can now just start the server. Okay, we install the package. Okay, this is a Vite.js front end, very like simple. But yeah. Okay, so now I'm just going to open the terminal here. But yeah, just to see some stuff that's going to happen on the background, but you really don't need to. So yeah, here now you should be connected on scroll. You can just I'm going to use this account because this is going to be the relayer for me, and this is going to be the sender. So when you start, you see that it's going to ask you to connect to MetaMask. The first time it's going to ask you to connect through a button. You just click the button and connect as a normal dApp. And then this dApp can also read the state. So far there are no comments, so we're going to send our first comment. So okay, so this is going to be the title, and this is going to be the text. And when we send the message, this is where the experience gets a little bit different. So the first part is that we're going to need to sign a message. And I really like this because since we're using EIP 712, which I mentioned before, you can see very clearly what you're doing. Here, this is the title, this is the text, it's very clear. You're interacting on this blockchain, and also in the background, you can see this, but in the background, you're also like, it's also going to check if the smart contract is actually the smart contract that you're is actually the smart contract that you're going to you wanted to interact with. It's going to be that check that's going to be checked on the smart contract. Yeah, we can go back to the smart contract later and check that. But yeah, so here the user only needs to sign. And now it says this here that it's generating a proof, and it's generating the proof in the browser. So yeah, just using WASM, which is basically like some sort of assembly stuff that you can run on your browser. As you can see, it takes a lot of time, maybe around a minute to generate a proof. But yeah, I'm really so impressed and so happy that we're able to generate a proof like in a minute, because if you know, like the first implementation, like the first widely used implementation of CK was seed cash, and so the first demo before the launch, they wanted to send just money from account A and to account B using CK, and it took like, I think it was like 12 hours in their first demo. But now in minutes we can like verify ECDSA with this nice MetaMask pop-up, and we can sign any message in just very, very quickly. So yeah, as you can see now the proof was generated. And if we go to our relayer, here you can see that it generated it just relayed the proof with all the inputs. We can go to scroll scan and check it was successfully submitted. Here you can see we passed the proof that was generated on the browser and the public inputs. Oh, by the way, as you can see, there is some optimizations that can be done here. We can also talk about it. But yeah, the proof was relayed. We can just refresh here, and now the comment, you can see the comment now here. So yeah, that's the demo we have prepared for now. And yeah, just going back and checking like some cool stuff that happened for me. I think that it's really, really cool that we now can build applications that pass parameters, check some logic. It could be DeFi, it could be social, it could be gaming, but the user sending a parameters, they can hide any input, including the sender. So I think it's super nice, and there are many like designs that can be implemented on top of this. But yeah, I think this is like a good start, and hopefully this inspires you try it out and see like what ideas you can come out from this. So I don't know. I'm not in the chat at the moment, so I don't know if maybe on Raza you have anything that you want to share, or there are any questions on Discord or on YouTube.
Yeah, I've closed Discord because I'll go like the echo thing will happen again. So
Okay.
I'm not sure if Juan is still there, but if you drop it in the chat, it should come to Restream as well. But I don't see any questions in the chat right now. But yeah, I think the main question I have on my side is how long does it take to generate the ZK proof like client side?
Yeah, for me it takes usually like a minute, I will say. But it can be like a super big message and still take a minute. I think it's going to be reduced in the future. So I think it's not like optimal user experience to wait a minute for a transaction, of course. But it's going to be reduced in the future. So there is new cryptographic primitives coming. There's Nova. Everyone's talking about Nova, and this can be implemented here. You can also do some sort of proof recursion. You can send just a small proof, and then a bigger proof can be produced in a backend service. But yes, yeah, a lot of people are experimenting with different stuff. But yeah, so far it's a minute to generate a proof on your browser. What do you think about it? Is it still too bad of a user experience?
Yeah, I think for us like hackers, we love it. I mean, I remember when Wasm like they did an upgrade, we couldn't use Wasm, we were hacking in Barcelona, and I think at some point it took 2 minutes when the app actually got like big and stuff. We had to set up a service, backend service, and I think so. The first thing I actually like a question on my end is the ZKP stored on chain?
The ZK proof? No. Well, yeah, actually, that's a good question. Because it's not, you don't need to store it on chain. You just need to pass it as a parameter just to, you just need to pass the proof as a parameter to verify it. So if we go here, send proof.
Yeah.
So we pass the proof, but as you can see, we don't store it anywhere.
Sorry, go ahead.
But just keep in mind that all the parameters that you pass on layer 2s, you need to store it just to keep the layer 2 secure. You need to store it somehow on layer 1. So you could say that you store the proof on the on layer 1, but you don't really need to, like when we operate tank sharding, we will need to store the proof, and also on Ethereum, like on layer 1s, you don't need to store the proof.
Okay, but like the proof that's generated, that long piece, so it's generated client side, right?
Yeah, it's generated client side.
Yeah, but it's not pushed on chain. Mm-hmm. It is not stored locally. Mm-hmm. The question then is, once you generate that proof, you need to like store it yourself somewhere?
No. You just need to pass it to the relayer, or you, for example, if you don't want to keep anonymity of the user, you can just pass the proof directly to the smart contract. So just send the proof directly to the smart contract or to the relayer if you want to keep your anonymity. But you only need to pass the proof on the smart contract just to get verified.
Okay.
And once that's verified, that's it. You don't need it anymore.
Okay, yeah. So here's the thing. The reason why I'm asking is so it's not reusable. So it's actually session based. So you come in, you pass so it's basically you pass the parameters, the public input, the private input is the signature, right? Yeah. So you sign with MetaMask, and then it generates and verifies.
Mm-hmm.
So for instance, with DID, this wouldn't be usable because you would want to store that proof so you can reuse it every time you would authenticate.
With DID, what is DID?
So decentralized identity. So with decentralized identity, like Sysmo, unfortunately, like they stopped, but like you kind of like have an app, right? And it stores the ZKP, so you don't have to keep generating it. I mean, this is one way of doing it. I mean, you could still do decentralized identity here, I guess, because if your identity is linked to your account, but it's just that you have to generate a proof every time.
You need to generate a proof for every action that you want to do, or every time that you want to prove something, not everything, because that's the cool about ZK, right? That you don't have to reveal everything.
No.
To prove something,
but from a user point of view, let's say I come into your app. Let's say this is used to log in, right? So you pass some parameters, my name, and then the wallet address, and then I can log in. And so at that point, it generates proof and verifies it. Now I close the session, I close the app, I open it up again, and I want to log in again. It again regenerates that ZK proof and verifies it, right?
No. So a user experience. Actually, I haven't like tried that, but I think that you know you're you, so you don't need to prove to yourself that you're you.
No. But that's just an example. But what I'm trying to say is that when you close the session, the ZK proof is gone, because at the end of the day, that proof, that long hash, you don't like that long piece of code, you don't store it anywhere.
Yeah, you don't need to store it.
Yeah, but so you generate it, use it, and then what?
Yeah, you can just close your session and you can come back. But when you come back, you don't need to generate a proof to come back, only if you want to interact with the smart contract. So for reading, I don't think you need to generate proof for reading, but for writing, you need.
What if your app would be gated with a ZKP?
Yeah, I think it will depend on the use cases. Yeah. For example, if you're doing go ahead.
The way I understand it now is that if the ZKP would be used to gate the app, and you don't store, so it's simple. Like, let's take a step back. A simple terms, right? ZK. Let's assume the zero knowledge proof is the key, and the verifier is the lock. And so when I enter the app, I want to use that ZKP.
Yeah, I think it goes back to what you say. It will depend if the app is gated. But I also think that it will be like if everything is gated, maybe everything that you want to read is gated. I think it will be like a bad experience just waiting 1 minute to log in, 1 other minute to query your current state, and 1 other minute to submit any transactions.
But if it would only be like the gated part, the hey Junger, great to see you here. Sorry, I just see your chat now. But my point is that the verification is instant. The 1 minute is because of the proof generation.
Yeah.
So if the proof was stored somewhere, then if it's the gated part, you can actually do, like, you know how right now session-based keys are a thing in account abstraction.
Oh, I see what you're getting to. Yeah. You can store.
You only generate it once, and you are like, like there is like a question about the nullifier, so preventing double spending. That is something that will be a thing. But like, let's park that. The whole thing from a user experience would be that it would be as if you're signing up for an account, and you do that once, and then after that, even if I close the app, I come back, it's a session based, right? So I can just like go through everything.
Yeah, I think stuff like that could work. The only thing is that what if the state of the smart contract changed, and now your proof is not valid anymore? For example, if you are proving that you are part of a list of users in a Merkle tree. Okay, so you're proving that you're one of the users. So when you log into your site, you can generate a proof and say, okay, this proof, so this way I can see that I'm part of the members. So on the website it will pop up, hey, welcome back, member. But what if the state of the smart contract changes the list and now you're not part of that? So if you store the proof on the browser, like on the cache data, so if the root is not going to change, think it will be super nice because you already have a proof and you just go into the website and check the proof. Okay, I'm part of the smart contract. Good user experience. But if the state change, if the list change, you have to recheck again.
Mm-hmm.
So I think it will depend on the use case. But yeah, I think it's something good to keep in mind when creating this user experience. What things can you store on your browser or locally, and that can help to not generating a lot of proof later on, right?
Yeah, I think that so. Again, ignoring the double spend part because that's a huge issue. So I think the cool thing about this is that if you isolate that, I know it's a huge part, so someone listening is probably going to be like, yeah, but that's important, and it is important. But if you isolate that part, the cool thing about the ZKP is it's useless for someone utilizing it if it's not your account, because you can't sign it.
Yeah, exactly. Yeah. You can post it publicly.
Yeah. So the cool thing is you could post it publicly. So it's just so it is maybe. I wonder how much it costs to store it on chain, but I think there's a use case there to store it on chain if the nullifier operates effectively. And I get it. Like if the public input that decides, let's say the list of like an array of accounts, right? That is part of, let's say, the people who can generate a proof, that needs to remain unchanged. Because if there is another account in that address, like the way we did the Merkle tree, the ZKP is rendered useless.
Yeah, but I don't see like a use case to store a proof on chain to keep it available for something. Yeah, I don't see a use case for that. I can see a use case for what you mentioned before, storing proof on the browser just to not keep it. Yeah, just to just so you know, like when the front end, when you relog in, like you don't have to regenerate some proofs. I can see a use case for that, but on chain, do you see a use case for storing like on chain proofs?
I mean, if it's permissionless, right? Which means that I don't have to worry wherever I'm in the world. I don't need no account. So for me, the biggest use case would be that if I'm not on any of my devices, and now from another device I want to log in into an application, and want to, okay, my wallet is not done, but let's just assume I can connect to my wallet, then I can utilize that ZKP.
But you need to sign the ZKP.
Yeah. That's a good point.
And since you need to sign it, you still will need to rerun the whole thing.
Okay.
The cool thing is that you can post it publicly, so someone else execute it for you. That's the relayer, but that's the relayer part. But yeah, if you put it, you post it on chain, like, or publicly, anyone could execute it like whenever they want. So you can't just post it publicly and just execute it whenever you want. But because if it's public, someone else can execute it for you. Of course, they can't just like impersonify you or yeah, maybe if you use some sort of recursion, maybe
it seems yeah, I'm just trying to bypass the 1 minute. So this is still cool. It's a next step because again, we were hands-on in Barcelona and we had this whole backend service. We used, I think, Semaphore for the ECDSA verification.
No, we used back then we used Noir. Yeah, we used Noir, but it didn't have the WASM support. So we did it in. Do you remember we did it in a backend instead of Yeah.
But also the signing of the MetaMask, we kind of did it in a hacky way where we passed the signer object, sort of encrypted it, and then we used a third-party library to pass it as a private input to Noir because you couldn't do it directly.
Yeah. Now, here is different, right? Because we didn't do it this way because we only was passing like a very hacky stuff here. Yeah, I remember.
We didn't do copy paste, but technically speaking, because it was a servers running, I don't think we were exposing it, but it was also not like very secure.
Yeah, no, it wasn't.
We were, but like, hey, I'll take some pride in it. We're definitely not exposing it, but yeah, I forgot there was like some way you could grab it, but I forgot what it was.
Oh no! It was that you have to run a backend server. Yeah, I remember now. You have to generate the proof on a backend service, but the thing is that the backend server is on your PC. So
yes, and
so yeah, you want you don't need to expose your private key, but you need to run this external like server.
Yeah, and we had a .env, so it was very static. We had a .env with the private key that we loaded at the backend that would generate the signature.
Yeah. Super hacky, yeah.
It was super hacky, but it was fun. There was a bunch of other things, but yeah, I think, so I guess like the thing is that's our starting point, right? So our starting point is like you gotta like work a lot around it. But for a lot of people, this is the starting point where they're like, okay, cool, you can now do this, but it still takes a minute.
Yeah. I think it's. But I don't know. Did you use Aztec Connect or Tornado Cache or something like that?
Yeah, Tornado Cache I have not used Aztec Connect.
Yeah, I only use Aztec Connect, and it also took like a long time.
Yeah.
And yeah, maybe like more than a minute for sure. And you also have to do a lot of it was not like this. It was not like you just get in and sign a message and that's it. You have to sign a lot of message, produce a lot of proofs, and then wait for a lot of time. It was very. It took a while. I'm very optimistic about the proving time. Also, PCs may get better, and it will maybe faster to generate proof. Also, maybe in the future we can use maybe GPU proving from the browser. And I don't know. Yeah, I think there is a lot of room. There's a lot of people investigating a lot of stuff. Yeah, I agree that. Yeah, waiting a minute. It's very long, but maybe if you're using like the thing is that the things that you can build for this year are so new that I think it's worth to just give it a try and offer like something like a new product that people may get interested in.
But I got a question for you. So I got shared. Have you heard of Paima Studios?
No, what is it?
Paima Studios is a gaming studio, and they've created their own engine, just like Mud, for EVM. So today you can use that. I think it's TypeScript based, and Mud is Solidity based, and basically it has like a bunch of contracts, sets it up for you, and pre-deploy, so it manages states for you, so you can just like focus on, let's say, the game dev side of things. But they've been looking at ZK for a while, but it's still like, we're not there yet when it comes to ideally the gas fee, so to say, one of the things. So I think that what they did is with Mina protocol is they launched an L2 on Mina, and they created their own ZK layer. And what they did is they reused the circuits of Mina on that L2, and they even expanded on it. So one of the things that, what I think would be cool is, to what extent can you do ZK all the things and then use aggregated or recursive proofs to basically compress it so much so that it is the smallest bit of data only that you commit, but everything is done client side inside app and then committed on chain, like in an aggregated way, just like how we do at Scroll.
Yeah, I think we are now in the realm of layer 3s.
yeah. I'm poking.
Yeah, I think that's like good, like a good place to start, like to do a lot of research, because a lot of things can be done. And so, for example, here, like we are on a layer 2, and we are submitting a message using a CK EVM. So we're grabbing from there the scalability part, and we are creating a dApp with anonymity, which can become like a layer 3. So one layer for scalability and other layer for anonymity. And the question will be, how do you prevent how do you ensure that everyone is able to submit transactions, that layers are going to pass them? And that will be the question. But with recursive proof, I think it's doable. But there's also like security implications from that, because while you're doing all this proof aggregation on the layer 3, there should be like in terms of censorship resistance and even bugs, there is like some extra security concerns over there. But I think it sounds like a super good solution. Aggregating proofs and then store it on a layer 2 to save some gas. I think there is a lot of things that can be done, because proof aggregation, you can have the proof the same size but with many proofs aggregated. So instead of having like, I don't know, 10 or 100 transactions, you generate a proof of the 100 like Scroll does.
Yeah,
it aggregates proofs. So I think something that's super doable.
So here's my thing. Right now, the majority of the gas fees are L1 commit, right? So that will remain. So I think that obviously with what we're gonna do like soon, like it's on our roadmap, like with data compressing, and then with proto-dank sharding, that will go down significantly. But it needs to go down even more. So I think that this like what I'm trying to do is let's look at it isolate, right? So if security is not a thing, like on L3, because on we don't have to worry about L2, we don't have to worry about Scroll, and obviously we don't have to worry about Ethereum. So and assume that we have a proper trusted relayer set up, right? So my question then is twofold. Could you do everything quote unquote on chain? It's still on chain on L3, but then postpone the frequency you commit to L2, which eventually commits to L1?
I think it's super doable.
And then the second thing is, and that's a more general question, I'm still diving into it. How does the DA fit in, like Celestia or Avail? Because they settle on Ethereum as well, right?
No, they post it back. They can post it back to Ethereum, but they settle on, I think it's on Cosmos.
But they post it on Ethereum.
They have a bridge to Ethereum, but all data is stored. It's not secured by Ethereum. It's not verified by Ethereum.
Right. Okay, so they are misunderstood. So it's just a possibility.
Mm-hmm. Yeah, and so it's very cheap. I think that all of those are like good possibilities. Putting the DA elsewhere. I think also it depends on what you want to do. If you want to go to the cheapest of everyone, you may go to Celestia. If you want to have like maybe like a layer 3 with extra security, I think proof aggregation, that's what sounds like the better way to go for me.
I think this will be cool to explore. Like
I still haven't had the chance to explore recursive proving.
Yeah.
But yeah, I think it's something that would be super nice to explore.
Yeah, because the only thing would be is, I mean, I've also been looking at like state channels, but the problem is that if one party stops acting on a state channel, the whole thing is blocked. So that's I saw it in a hackathon project in Istanbul. It was sort of like mimicking an L3, but there were inherent limitations there. I'll send the article about Paima. They also actually explored that. I think the way to go is having your own circuits inside it, or like interacting with your application, but having your own circuits, generating the ZK proof, and then the question is, how far can you take proof recursion before you store it on chain?
Yeah. You can batch, I think, any amount that you want, but it will take longer time, right? Also more proving time, and just more time waiting for users to submit transactions. But I think there is not a limit for recursion.
So performance is here a thing, but it saves gas fees, because instead of every state change that you post, let's say on Scroll, you would post, let's say, once in 100, but it's still on chain and it's secured by zero knowledge.
Yeah, I think it's super, and the concept is not so complex. Maybe I'm saying this because I haven't tried it yet. But the idea is just that you submit a proof that has another proof of parameter, and you check the proof on the circuit. That's the only idea. Maybe let's see if Socrates. I don't know if it may also have like recursion. But yeah, I don't think there is like some sort of I think you can just aggregate like thousands of transactions, and that's not an issue. Oh, so Socrates. Okay, so at this point, Socrates doesn't have recursive proof on the EVM. So you can generate basically this one. Their verifier that look like this can't verify recursive proof currently, but yeah, I think it's going to be fixed soon. Noir does have them, like they have some examples about it, and they do support. Hopefully there are no bugs in there.
I'm thinking about this because it would be nice to do something like Mud combining with Noir, but then not posting every state change to like on chain, but posting state changes to the circuit and then generating proofs, and keep generating proofs as long as you can until it doesn't become like a bottleneck. So what I mean is like you mentioned, like proof generations become like can take very long when you you continuously recurse or aggregate proofs, right? And at some point you do need to post on chain. So the question is if it's at the end of a session or like at what point, right?
Yeah. For example, let's say if you're playing rock paper scissors, and or chess, for example, if you're playing chess, and then you can, for example, I make a move and I generate a proof of my move and I send it to you off chain, and then you make your move, generate a proof, and send it back to me. We just like this, right? You give me your move, and I verify that it's valid on my circuit, and then I make a move and send it as a parameter, generate a new proof, send it to you, back and forth. So that's the recursion, and in that case, you only need to submit the latest one, like the when the match ends, and that will be verified by the contract. And the two things that comes to my mind is what happens if someone else stops interacting. For example, in the chess example, if I send a proof to you and then you never send a proof back to me.
That's the same with the ZK state channel. If you use ZK state channel, that's the same issue.
Mm-hmm.
The whole process stops. So
yeah,
I don't. That's why what I think. PvP is something else. So you would have like playing against someone else, but the first part would be you playing like yourself, like PvE. So against the computer, so like a Pokemon kind of game, right? So the first thing is actually if you move your character around, every move is actually a transaction when you use mud.
Oh, that sounds crazy to me. I want to check it. I haven't checked mud, but yeah, that sounds super crazy, and I want to check that out. Yeah.
A friend of mine is doing a workshop soon, like I think next week somewhere. I'll post the link, and he'll give you the full rundown. He's actually doing like a Pokemon kind of game, so fully on-chain. But what would be cool is if you generate a recursive proof for multiple steps, and then you post that.
Yeah, the old school save game, right?
Yeah, exactly. But here's the thing: in order to qualify to be fully on-chain, it shouldn't be the save game, or else it's no different than, you play a game, and at the end you kind of mint an NFT.
Wait.
So remember, gaming right now exists in Web3 in two stages. Gaming, I would say 2.5, where we just have normal gameplay. It's not on-chain. It's just like in the cloud, like blah blah. And then at the end, you can like kind of mint an NFT, or you get tokens at the end of the session of the game, or you have like an NFT as a skin, and it just reads from the blockchain. If you own that NFT, your car gets a certain color, right?
Yeah.
Then you have the other side, which is autonomous worlds, fully on-chain. Okay. Everything is on-chain.
Okay.
Now, one of the requirements of being on-chain, not sort of, like there are different opinions here, but one of the requirements is, so what MUD does is, every move, everything that you do in interacting is recorded on-chain. Now, with the recursive proof, technically speaking, it's also recorded on-chain, everything.
Everything is going to be in the future recorded on-chain. There's just some small time that it's not on-chain. I don't know if that's too much of a stretch for this like 100% on-chain philosophy. But yeah, I think it can make a good case. Yeah,
I know, right? So here's what I'm thinking. It's like, I think it starts with just moving a character from left to right, and then for the duration of 5 steps, instead of like waiting, because sometimes you have to wait to move the character because it's not done with the transaction yet. And so instead of that, you would have like the character moves flawlessly, and then it posts the ZKP, and it should also be cheaper, right?
Yeah, way cheaper.
Yeah. Okay, we gotta explore this, because I think there's something. So William is saying, if you want playing an MMO or open world, is it a problem? No, it is a little bit of a problem. You need to mint a new so usually what happens is, in this case, this data is on chain already, and you kind of like download a state, William, and then what happens is your character is moving around, so that you got a map and a tile, and it's all in a data schema. And then what happens is like there's just an additional let's say element in the array that keeps track of where you are, and that's recorded continuously. We'll do like there is going to be a friend of mine is doing a workshop on it, but we'll do one as well, playing with mud on scroll soon, in the next build session maybe. But it's the main problem is that it's gas intensive, on any L2. It doesn't matter which L2, it's on any L2. So what's being explored in the gaming world, because they cannot go around ZK, because the arbitrary period of the OP rollup is just kind of an issue. So and the gas fees. So now what they're exploring is state changes using ZK circuits.
Yeah, for me that makes a lot of sense. Yeah,
right. And so what would be cool is to use Noir with Mud. Just saying that.
Yeah. I think Noir can bring the recursive part and also good user experience because people can sign with your MetaMask wallet. And Mod can bring all this new like structure. I think that would be like a super good combination. Yeah, for sure.
We kind of just need like a 4-hour block where we just like dive into it.
Yeah. It sounds super good.
Yeah, maybe if Juan is taking notes, maybe we can just do it live as well. We just like go dive into it.
Yeah.
I think we're coming up at the end of our session. I don't see any more questions in the chat. Quickly checking if Juan is around, but I think we can call it a day. Thank you, Ahmed, for that walkthrough. I see an emoji face, blue, white eyes. It's described. But yeah, it was thank you everyone for joining. Really appreciate it. Hope the walkthrough was of value. We know super happy that Noir is actually usable on Scroll today. Like I mentioned, the only ZK rollup right now, so that's super dope because of all the pre-compiled support. Again, shout out to Ahmed. Stay tuned. We will do more of these LoFi coding sessions, and definitely let us know. Shout us out left or right, wherever you want. So if you like this and want to see more of us.
Yeah. Thanks everyone for joining. And also, thanks Edward on the chat for helping everyone else. And Mart, saludos, Dagger, Jamal, Sadbir, and WebDev. Thanks everyone. Just for joining.
All right, guys.
All right. Before you guys leave, though, just want to give some sort of announcement. Our next call this coming Friday. Raza, are you jumping on there?
I should be.
Putting you out there in public. Okay, so we can expect Raza to be online on the next call this coming Friday, office hours. Don't miss it. You're going to be able to meet new other people from the team, which is always exciting. And thank you guys for jumping on this very first LoFi coding session. Let's keep it constant. Let's see how far can we go in a streak here. And ideally, we can have different guests coming up in the near future. Maybe we can even make a survey and see what people want to see built in the near future. So you communities, you guys own these initiatives, so please do make suggestions and provide feedback whenever possible, and we'll surely take that. With that in mind, thank you guys for jumping in here. Appreciate it tons, and take care. Peace.
Take care, guys. Bye-bye.